Hi, everyone. We are now live, and welcome to the first Machine Learning for .NET Community Standup. I am Bree. I'm a PM on the .NET team working on ML.NET, and we are starting this series. Super excited to talk to you about machine learning with .NET and ML.NET and all the community contributions and all these things that are coming up with the framework and tooling. So I'll hand it over to Jake and Louise to introduce themselves as well. Jake?
Cool. Hello, I'm Jake. I'm the dev lead on the Model Builder tools and the CLI as well. I lead an awesome team and was one of the first developers on the tooling to bring Model Builder to you guys.
Awesome. Hey, I'm Luis. I am part of the Microsoft Docs team, and among many things, I work with Azure Machine Learning, .NET for Apache Spark, and of course, ML.NET.
Awesome. So since this is our first introduction, our hello world, I will talk to you all a little bit about what is machine learning. Very quick 5-minute intro. Talk to you a little bit about the ML.NET framework. Then we'll start digging into some community links, and then we actually have a super passionate community member on who's going to talk about his project MLOps.net. So bear with me. This is my first time working all these tools for streaming to you all. So let me get started here. Awesome. So just a few slides, I promise. This is my 5-minute what is machine learning, and hopefully by the end of it, you are all experts. No, I'm just kidding. You all understand the basics if you don't know them already, and understand all the different things that you can do with machine learning. First, we'll start off with artificial intelligence. So this is the ability of a computer to perform tasks normally associated with humans or intelligent beings. So this can be things like reasoning, generalizing, and usually this starts as a rule or a logic-based system. So you can think of a lot of if statements. And so if I go to this next example, a problem to solve. If you're looking at, is this bread or not bread? If you're using artificial intelligence to solve this, you might have a bunch of different if statements. So, if it has ears, then it's obviously not bread. If it has eyes, it's not bread. But you can see that this can be really, really hard to scale because there's a lot of different features that can make something bread or not bread. So while artificial intelligence as a whole can be used to solve some problems, there's actually a better way for ones that might have a lot of different features or if you need to scale that up. And that's where machine learning comes in. So machine learning is a subset of artificial intelligence. It's getting computers to make predictions without actually explicitly programming them, so without having all these if statements. So what happens here is computers will find patterns in past data, learn from this experience, and then use their past experience to act on new data and make predictions. So again, it's used to solve problems that might be difficult to solve with traditional rules-based AI. And as an example, with the bread or not bread, instead of having all these if statements, what you would actually have is a bunch of examples of bread and a bunch of examples of not bread. And you'll use an algorithm to train a model and then use this model to use its past experience to predict if this new thing is bread or not bread. Another way to look at it, if you're looking at artificial intelligence, the input is going to be the rules like those if statements and the data. And what you're going to get from that is answers. Whereas with machine learning, you'll actually give it data and answers, and then the output would be the rules, which you can use for new data. And then there's deep learning. So deep learning is a subset of machine learning. It imitates the way the human brain learns and thinks, processes data. This is used for more complex tasks like image classification or object detection or natural language processing. And how this all fits together, you've got artificial intelligence. Machine learning is a subset of that. And then deep learning is a subset of machine learning. So that's how all the pieces fit together. And then there's a lot of different things you can do with machine learning. And here's just some of them. You can categorize email as spam or not spam. So that would be a classification example. You can predict the price of a house based on house features. That would be a regression example, or predicting a number, or predicting sales based on past sales, recommending products to users. So there's a whole bunch of different things you can do with machine learning. So from here, I'll start talking about ML.NET, and I'm actually going to show, this is the main landing page for ML.NET, and we will hand out all the links that we have up here, all of our community links as well at the end, or maybe after we show all the links, we can paste it into the chat. But what we have here, ML.NET. So what this is, it's an open source and cross-platform machine learning framework for .NET developers. So what this means is you can build custom machine learning models using .NET. You can stay in the .NET ecosystem. You don't have to learn languages or tech stacks that are commonly associated with machine learning. You can stay in the .NET ecosystem and use the tools that you're familiar with. And then we also emphasize it's for developers, or at least we target developers because we know that a lot of developers don't have data science experience, and we want to make it as easy as possible for them to be able to add machine learning to their .NET applications. So the tools that we have enable developers, .NET developers, to easily do this. So you can see we have a few of our value props here, a little bit of the history. ML.NET actually started as a Microsoft research project, I think about 10 years ago. And it was an internal framework called the Learning Code that was used by a ton of different machine learning features and popular Microsoft products. So that could be it's used in Power BI, Microsoft Defender, Bing Ad Predictions, Windows Hello. So it's been used for a really, really long time. And then in 2018, it was actually released at Build. It was open source, made cross-platform, and made a little bit friendlier for external usage, and it was renamed to ML.NET. So the first preview release was 2018 of Build, and then last year, 2019 Build, it was actually the first GA release, and also our tooling releases. So I'll scroll down here, and you can see here's some of the examples of things that you can do with ML.NET. Again, these kind of map to the slide that I showed with what can you do with machine learning. And there's a whole bunch of different things. These are just some of the examples. And actually, if you follow this link here, it takes you to our samples repo. And actually, I have it loaded right here. And there's a bunch of different samples that you can use to get started. Another great way to get started is our tooling, which Louise and Jake will actually show in a little bit. So yeah, that's the very basics. Louise, Jake, was there anything you wanted to add before I start jumping into the community links?
No, I think this is great.
Awesome. All right. So now that we have the, I heard something. No? Okay. Cool. So now that we have these, and I forgot to zoom in so you all can see, but we'll, again, be handing out the links after. Let's jump into some community links to show what people have been doing with ML.NET. So actually from our machine learning samples repo, we actually have, let me zoom out, if you scroll down to the bottom, we actually have some community samples. So these are ones that are maintained by our team. And of course, we always love having community contributions to these, but we have actually community samples which are created and maintained by community members. So I will show this. So here are just some of them that we have. One of my favorite ones is, let me see if I can find it here, is this ML.NET and Visual Desktop UWP app. It's because it's really easy to see all the different applications. And this is by GitHub alias Samuel Brewer, and I believe it's, oh God, does anyone know how to pronounce Diedrich, maybe? I feel like that's right. I'll confirm that later. But I will show, so you can see there's a bunch of different examples here where they implement ML.NET into a UWP app and make it really, really visual so you can see what's happening. And they have a bunch of different examples: clustering, multi-class classification, binary classification. So you can see that they go on, and even some of the features that ML.NET has, they showcase in this very visual way. So that's one of my favorite community samples. Another one, which is up at the top here, is this COVID-19 exploratory data analysis. So this is actually Praveen, who presented at the first virtual ML.NET community conference, which we had earlier this year. And he added it as a sample. So he does some data analysis with Jupyter Notebooks and .NET, and then actually uses ML.NET to make some predictions. So yeah, if you go to this page, you can see some more of the community contributions on the samples repo. And so then I move on to YouTube. My links are a little slow. So this is actually John Woods.
So I guess one takeaway from this, right? Yeah. Oh, sorry. I was just saying that one of the takeaways, right, is that there's multiple ways to contribute to these samples. We certainly welcome them. If you already have an existing sample, you can either submit and add it to the list of existing .NET, machine learning samples, or you can, of course, just provide the link, and we'd be happy to add it to this community samples sort of collection here.
Yeah, thanks, Louise. Yeah, and so this is John Wood's YouTube channel. John Wood is another super enthusiastic, passionate ML.NET community member who has created a ton of videos. They have a whole ML.NET playlist that ranges from how do I start with ML.NET to more end-to-end scenarios or more advanced scenarios, and he's always adding new ones. So I'm sure we'll have him on the show at some point. He was one of the organizers of the community conference that we had earlier this year. So definitely encourage you to check this out if you're just learning or have a specific thing that you want to learn with ML.NET. And he's on Twitter as well, so I'm sure if you had a specific scenario or feature that you wanted to see, you could reach out to him and he'd create a video. He's awesome. So we're starting to actually see a lot more YouTube videos and tutorials and lessons online about ML.NET, which is really, really awesome to see. So you can see here we've got Kaushik Roy Chowdhury, who created this introduction to ML.NET, and again has a ton of different ML.NET videos here. And it looks like he creates some Udemy courses, so you may see an ML.NET one soon in the future if there's not one already. And then another example, which Louise actually found, was they used ML.NET to predict how nice are your Discord users. Specifically, it's a bot that looks at your messages on Discord, and it sends those messages to the machine learning model and will predict if it's nice or rude, which I think is really cool. Sentiment analysis, or predicting the sentiment of a comment, if it's positive or negative, is actually really popular, especially when showcasing machine learning. So Louise, did you have anything you wanted to add? I know you added this link on there. So
yeah, no, this is actually really, really cool. I actually was not aware of it until a few days ago. But yeah, it's really nice to see that folks are taking, ML.NET and building all these very interesting applications.
Yeah, definitely. Let's see if this will load. Yeah, so it's on Azure DevOps, and that's you can sure check it out, the README. I'll have to try and run that later too. I haven't dug too much into it. So then we've got Alexander, who is actually on the show. He'll be on later today. He's made a ton of different contributions to ML.NET, including his MLOps.NET project, which he'll talk about later. But he's also just started on this ML.NET templates project, which creates new ML.NET templates using the .NET new command. So this is really, really cool. I believe he just started this, last week. So super excited to see how that develops and see if, eventually integrating it into VS as well would be really, really awesome. So that is the first round of community links for this show. There's one more thing I wanted to show off in this .NET site, so the main landing page, which again, we will send out those links. If you go down to this trusted improvement at scale and read customer stories, this is actually a showcase of our customers and how they're using ML.NET. So I've actually written these stories so that they're pretty short, and you can kind of get the business problem, what they're trying to solve, why they chose ML.NET, and if they wanted to share what their solution architecture looked like. So let's go into ScanCam, for instance. They are an Australian company who wanted to solve the problem of fuel theft in Australia, and they are actually using ML.NET for object detection to detect cars in images, and then the license plate, and then searches a database of previous offenders. And you can see here they talk about why they chose ML.NET, and of course, the main reason we usually get is, well, we're a .NET shop, or we're all .NET. And we want to stay in .NET, and integrating, being able to use .NET and C# was just the perfect for us. They talk a little bit about the impact and the solution architecture. So if you want to check out some real life examples, and I'm always adding, or trying to always add new stories to here as well, or if you even have a story yourself and want me to add it to the showcase, reach out, and we can definitely get it added on there. And from there, I'm actually going to turn it over to Jake to talk about some exciting features that we just released. So let me switch over. All right, Jake, take it away.
Can you guys hear me? Cool. So we just released GPU training for Model Builder. I'll kind of go back to the beginning here. So for kind of going back to how Bree was describing the AI and ML stuff, one thing is that when it's with ML, when it's trying to figure out and learn the algorithms, it's computationally intensive. And so GPUs can actually do that much better than CPU. And so right now we only have GPU training lit up for image classification. That image classification, because it uses the deep learning, the neural networks, it is even more computationally intensive. So you kind of get the most gain by adding GPU training to that. So if you come through and you're in and you select image classification, you can now choose GPU, choose your data, and train. And when you train, this will now leverage your GPU, and it's about a 5x improvement over CPU. There are some caveats though. You need a NVIDIA GPU or a compatible GPU for the training. But once you get it set up, ultimately we'll just get you models faster. So I'm pretty pumped to kind of make the iterative process on image classification a little bit less painful, because let me pull up my numbers here just to give comparison. So I trained, I don't know if we've actually done a demo in any of our public stuff for this, but we have like the American Sign Language data set that we've trained against for like just trying to interpret some of the sign language. And it has about 80,000 images, and on CPU that takes like 4.5 hours. And with GPU, it knocks it down to about 40 minutes. So it's a pretty huge cost savings, and makes it so that you can get right to coding and integrating it into your applications.
Hey, Jake, do you want to talk a little bit more about the Model Builder tool in general?
Sure. So yeah, I don't know if we've really stepped through this much. There are definitely videos that Bree has done for kind of walking through this, but I can navigate a little bit. So on this first page, you're just going to kind of choose your scenario. So text classification, Bree kind of touched on one of the examples earlier with sentiment analysis. It'll take in like free-form text and categorize it. So with sentiment analysis, that's specifically 2 categories. But with our tool, we actually don't differentiate, at least on this screen, between the 2 categories or n categories, 10 categories, whatever. So in there, you can, based on your data set, you would have labeled strings and then categories, and then toss it into Model Builder and train on it. For value prediction, that's kind of like the numeric prediction. One of the classic examples is like having all the features of a house and trying to predict its value. Image classification, that's kind of one that I can click through later and show you exactly how it works through the product. But it categorizing. It's kind of like text classification in the sense that it's classification. So you're still just kind of labeling it, but with image classification, it's based on just image data and not text. And then, for recommendation, that's trying to give you recommendations, just like Netflix would give you recommendations. And object detection is a new feature that Luis is actually going to talk about in a little bit, but it's somewhat related to image classification. But I'll let Luis kind of talk about it more in a bit. So for a lot of those, there's only going to be the CPU training, but you would come in here, choose your different options. For this specific example, we have local GPU and Azure. So in Azure, you're going to get even more performance improvement. It's going to search over more models. and it's going to free up your resources on your machine so you can keep developing. So if you have something, I gave you numbers earlier about the 80,000. You can imagine if you don't have a compatible GPU, it'd be nice to not tie up your machine for 4 hours and instead push it out to Azure and get a result back pretty close to the same as the GPU training here. But over time, the Azure AutoML team is doing a great job of sort of ramping up how well it scales and the speed of training. So then you would train in here. So I already have this trained, but normally you would just click Start Training, and it would take, so this one was 302 seconds. I can't do the math, so like 5 minutes. And then once it's done training, you come to this evaluate screen, and here you can pick a different image. In the case of image classification, for the text ones, there would be text fields here, and you would choose between them. And then it'll go ahead and do a prediction. I think it's running a little slower since I'm sharing my screen, and tell you that it's cloudy. So this is just meant to give you some insight into the model that you've trained, start to build some confidence that it actually trained a model that can do what you were intending. And then from there, you can take that model, generate code, which will add it to the solution here. And in here, there's some helpers to actually load the model, perform the predictions. And so you can kind of see, like, this basically just takes in an image path, and then it'll predict the label and give you some scores. So we try to make it easy. If you have any issues, reach out to us on GitHub or in our next community stand-up, and we're happy to help. And that's pretty much it.
Awesome, thanks, Jake. Yeah, so just to emphasize, before we, how do I put this on? There we go. Oh, wow, that's weird. There we go. So before we, Model Builder only had CPU training for image classification, and it was really, really slow. And especially as you started to add more images to your data set, and as you start to add more classes, then we added support for Azure training, which did help that a ton. But we still wanted an option, a faster option for local training for those who didn't want to use the cloud or wanted to test it out beforehand. So now we have GPU training, which is really awesome. The image classification API for training image classification models that ML.NET offers also has GPU support. So that's really cool. And now Louise is going to talk about something that we are releasing soon in our tooling. So Louise, if you go ahead and share your screen.
Let's see, share screen. And of course, it wouldn't be a live stream if something didn't go wrong. So I will, bear with me as I kind of talk through this, but there will be things that you won't be able to see. Again, also keep in mind that this is some early work at the moment, and it will be released. I'll let Bree handle the hard questions there in terms of when. I'll take the easy questions. But yeah, 1 second here while I share.
All right.
I think it's sharing the right screen. There we go. All right, so this screen should look familiar to you. And basically, the other scenario that Jay kind of alluded to earlier was object detection, right? So object detection, for folks who may not be familiar, it's also a computer vision problem, except that as opposed to, for example, image classification, you're just trying to determine what's, basically classify the images. With object detection, you're actually able to pinpoint where in the image certain objects are, right? And you're also able to classify the different types of objects. So you can imagine this being very useful in scenarios such as self-driving cars, right? You need to be able to detect pedestrians, street signs, and things like that. Another scenario would be, for example, if you're in manufacturing, right? Perhaps you have an assembly line, and you need to find if whatever it is that you're making in your assembly line, perhaps there may be cracks or there may be defects in the product that you're making. Object detection is actually a really good way to sort of use machine learning to solve that type of problem, and that way you don't necessarily have human errors or you can minimize the human error involved in the process. So again, this is something that's available. Again, it's very familiar, or will be available in Model Builder. And this looks very familiar, right? You start off where you normally would with going to your scenario. In this case, I went ahead and clicked object detection here. And you can see that you have the option to go ahead and train on Azure, right? And it's very similar to the image classification scenario. You also have that option to train on Azure. And the way that this works, right, is you have this machine learning workspace. You can think of a workspace as this place that essentially collects all of your resources that you would need in Azure machine learning. So that includes your computes, right? So the actual VMs that are going to be used to train your models. And once you go ahead and provide these things, right? Sort of go here, a workspace name, right? You can create one if you don't have them already. And once you have gone ahead and created an experiment, you go ahead and select your data. So currently, the way that the data format is in this sort of JSON format. That being said, though, this is, again, it's still a work in progress. So we would greatly encourage you to provide your feedback if you're working with object detection scenarios. What ways do you prefer to format your data? How are you storing it? So that those things can be taken into account as this feature and this scenario continues to be built, right? But assuming that you have something like that, right? Let me go to downloads here. Bear with me while I get the actual folder.
Can I add one thing while you're finding that, Luis? That's actually what Luis said about the data is true for all of our scenarios. Like, if you can reach out to us, let us know like where your data is, like how it's currently stored, so we can help make that process easier for you to kind of integrate it into Model Builder. Right now, we pretty much just support text formats and a little bit of SQL connections. But if we can make that early process of getting started in Model Builder easier, we'd love to hear how.
Yeah, certainly. And something that I kind of skipped over, right, was that the tool that it might make it easier at the moment to do this formatting, right, is this tool called Bot, right? And Bot, you provide images and you can tag your images, and then eventually you can export your tags of those images into the JSON file, as I mentioned earlier. And that's going to give you a nice format for that Model Builder will be able to handle. Now here, what you should be able to see is an image, and the types of images that we're kind of working with are cats, and we're trying to detect cat faces, right? So in this case, we would have a bounding box around this cat, right? So you should be able to see a bounding box around here, and that's kind of what you're seeing here. Whoops. Excuse me there. All right, so that's kind of what you're seeing there. So once you have everything set up, you have your data, you have your environment, you go to the train, and then after this, it's literally the exact same steps that you would otherwise do with Model Builder that you're probably used to, which is you train, you evaluate, kind of like what Jake was demoing, where you're able to make sure that your model is performing like it should, and then it generates code for you so that you can then consume it inside of your ASP.NET or whatever end user application. So definitely stay tuned for that, and we know that it's something that the community really is passionate about, and they really care about the scenario. So the team has done a lot of great work in sort of putting this together. All right.
Awesome. Thanks, Luis. Now I will attempt to. Oh, wait, it put it back for me. Awesome. So yeah, those are just a few mini demos to show off. New feature we just had, a new feature that's coming up. Some other things to look forward to besides object detection. Our other tool that we have is the ML.NET CLI. So that's our cross-platform tooling offering. We're about to add image classification to that to have that scenario parity with Model Builder. We have some training improvements coming to Azure as well. So it'll be a bit faster. And then we've got where the eventual goal is to add every scenario that ML.NET supports to AutoML, or that automated machine learning, which is what powers our tooling. so that you just have to provide your data or select your scenario, provide your data, and then get that trained model. So we're looking to add all ML.NET supported scenarios. So that would be things like forecasting and we already have recommendation, but forecasting, anomaly detection, and a few others that are not yet supported. We also are looking to add some advanced options for data loading. So right now you just put in your data and you don't really have any options for selecting what the separator is, or what if there's a header or not. So those are things that you're going to be able to do now, or not yet, soon in Model Builder. And then we're also looking to add a sort of reentrancy. And what this means is right now when you close out of Model Builder, if you want to open it back up, it creates a whole new session. So if you've already trained a model, you have to retrain that. So we're looking to add in a way to save the state of where you were at, be able to save that between people, and so on. And then another big thing that we're looking to add is MLOps integration. And Alexander will talk a little bit about MLOps, but in short, it's DevOps for machine learning. And so I think with that, I'll actually hand it off to Alexander. Let's add, hey, Alexander.
Hi, how's it going?
That is great. Thanks for joining us. We're super excited to hear about your project.
Awesome. Well, thank you for inviting me. I did not prepare any slides or anything, but I'm more than happy to share what I've been doing and working on and talk more about that.
Yeah, definitely. If you want to share your screen, we can pull up or show the GitHub.
All right. Let me see if I can.
Yeah, if you want to talk about what MLOps is, just a brief little thing and why it's important.
Sure. Let me see if I can share my screen here. Okay. Let's see which screen it chooses. Okay, perfect. That one I can share. All right. I think I am sharing my screen. I am. Perfect. Yeah, so I am, as Bree mentioned, heavily invested in ML.NET and really enjoy being part of this community. I think it's a great library, and I'm trying to extend some of the capabilities the library currently has. And one of the things that I was working on when I was looking at building machine learning models, it was earlier this year, I think, and I think Louise can attest to my questions, was that once I had a model and once I got this process up and running, I had no real good way of putting into production and managing it, and where would I store these things? How do I track metrics for how good a model is, and how do I know where my data is or if it's changed? How do I know which algorithm I used for one version of the model and the second one and so forth? And of course, I mean, as I went about this, I discovered tools like MLflow that's out there, or Neptune and Azure Machine Learning, that's a great service as well, and AWS SageMaker and so forth. That can all help with all these things. And the general question I had was, how can I automate my machine learning training and deployment, just like we do with DevOps as a software engineer, right? And kind of just integrate everything very nicely. The issue I was struggling with is that neither of these tools supported .NET. So MLflow, even though it says it supports every machine learning library, does not support ML.NET, which is unfortunate, because it's a great tool otherwise. And I also wanted other capabilities than just being able to be in the cloud. So although AWS and Azure are great ways of training your models on clusters and managing those in Azure Machine Learning, I also wanted the ability to do it locally and as well as in the cloud. So I set up in May, I think, to start building this tool called MLOps.net. Luis, you can thank Luis for the name, because he was the one suggesting it, which I think is an awesome name. And the idea behind the tool really is to kind of simplify this training process and simplify everything around machine learning. Because once you start doing some of these models, and especially with ML.NET, you'll find the process being very repetitive, and the same kind of steps, just different kind of data, different kind of transformations and algorithms, but the general flow is very repetitive. And there are a lot of things that's added to the complexity here that really wasn't part of software engineering. Like, when we have code, we store it in GitHub or TFS or somewhere else, and we deploy it to production through a DevOps pipeline, and we have this tight integration. But when it comes to machine learning, there's so many more things that can change. We have the code can change for how you train your model. The data can change. The configuration for your GPU clusters can change. Then you have versions of models, right? The models themselves can in production become stale and slowly deteriorate just because the surrounding environment changes. So it's a pretty daunting task when you start looking at this on like how to manage MLOps and how to make sure you get the best out of your model and successfully deploy it to production and continue adding value for your company. So what this tool is really supposed to do right now, and we're building on it, and we'd love your support, is specifically experiment tracking. So tracking, an experiment, meaning, for example, as Lise pointed out here, detecting cat faces on pictures. And then for each time we try to train a model, we have a run, which have things associated with, like evaluation metrics, how good it was, hyperparameters, so how we fine-tune that model, but also things like tracking, where's the data? Where did you get it from? Has it changed since last time? If we're using classification for fraud, things like data distribution is very important to ensure we have balanced data. So tracking those things are good. And when we have a model that's fully trained, where do we put it? So we need some kind of model repository. And currently we support Azure Blob Storage and AWS S3 buckets, as well as local file shares if you want to. But this model repository is useful because you can get these versioned models. So if you have a run that is better than the previous one, we can then add versioning to this, and also the full audit trail of where did this model come from, who trained it, what data was used for it, and so forth. So you get this auditability, so you can be accountable for your clients and whoever consumes your model. And finally, what we're currently working on right now is the deployment phase. So how do you deploy and consume your model? And I mean, that's a really cool thing with ML.NET, right? You can do it in so many ways because it's .NET. So you can do it as like an URI-based deployment, right? You can read the model from a location wherever you want to. You can embed it. You can put it in a Docker container. There's many ways of doing it. Currently, we support URI-based deployments. So we will track that for you and manage all those things for you. We're currently working on the Docker deployment to automatically generate these images and push them to your clusters and track all these things for you. And one thing I think is really cool with this, as I've been working on this, is that you don't need to supply dependencies. You won't need to supply like piping stuff that you need for scikit-learn or Python. For example, like, okay, here's my entry point. This is how I call the model. This is how I transform the data before calling the model. These are my packages you need to, do. Like, I'm hoping we can skip all that stuff because we can use reflection to figure out which package dependencies we have. We can use code generation in C# and .NET new templates to do all these things for us. So it should be as easy as just saying, okay, I have this model. Please create an image of it and push it to this cluster. And I don't want to worry about all the complexity that's around, deploying a machine learning model. So there's a lot of work being done here, and hopefully at the end we will have a client as well that you can visualize, compare runs and all these things managing through a UI. But so far we have a NuGet package that's deployed here. You can use that. Lots of people are contributing here. I will definitely want to highlight Brett Parker. I want to highlight AJ from New Zealand, and tons of others as well that is continuously helping out building this library here. So it's definitely completely community built and based. And if anyone wants to join in and help out, or if you want to use it and provide feedback, that will be even more valuable.
Awesome. Thanks, Alexander. Could you actually tell us a little bit more about, now that we have you here, your ML.NET templates?
Absolutely, yeah.
As well?
So that was something that I started creating just because we needed them for the Docker deployments. So the idea behind the containerized deployment, right, is to more or less deploy a registered model, but without having to supply exactly what the schema is for input and output and the ASP.NET Core API that the model should be wrapped around. So we needed some good way of automatically generating an ASP.NET Core API for ML.NET that exposes the model through an endpoint and all those things. So instead of building them into a library completely, I realized that you probably want to use them for many purposes, right? So we may want some for training, we may want some for embedding and deploying a model and so forth, and all kinds of stuff. So we have a package as well up for that, and we only have 3 templates so far, but they're pretty quick to create. And if you have any experience with .NET 2 templates, you can definitely chime in anyway. For that matter, it's pretty straightforward, and we would love more examples. So if there's something you want to create, open an issue and start collaborating on it. That'd be awesome. Or just open an issue and we'll create it for you. But the way you can use it, just to kind of give an idea here, we can do to this by installing the templates from NuGet. For example, we currently have a pre-release. So you can hit .NET New install and the template version here. And that will install them. And just like any other template here, they will now show up in your little new templates here. So we have 3 that comes with this package. We have one for a web app and two for console apps. So for example, we have one here that is for training that also includes MLOps.net. So you can do all those things as well. So let's see if we, for example, if we create a new directory here, standup, and go into that, we can then do .NET U here, MLNet training MLOps, I think. Let's see if that works. And that will generate this template for us for training with MLOps.net included in it. And then if we open up code, for example, VS Code here, just to see it, we can then look at how that template looks like and what it comes with it. So as normal, it comes with a schema. So we have model input here, and we can fill that out ourselves, depending on how schema looks like. And it comes with this pre-generated file here, which includes the general flow for how you're going to train a model. So if you've done this a bit before, you probably recognize this a lot. But you see how we load data from a file here, and we select our trainers and so forth. But in addition to that, it also comes with MLOps.net. So we can create a run here, down here, which is just defining, do we want to use SQLite, SQL Server, or Cosmos for backing storage for data? And where do we want to store a model? Is it locally or in S3 bucket or somewhere else? And based on that, we can then use that MLOps context that is kind of designed based on ML.NET to log data like this. So we can pass in the data view created by ML.NET, and then we automatically log things like what's the schema, what columns do we have, how does the data look like in general. And we can also do multiple more things here, as you see, like hyperparameters and training times and uploading models to the cloud or wherever you want to. And there's more ways of doing this as well. But in general, the library has been designed so it feels like ML.NET, and it respects ML.NET by doing it natively, right? So passing in data views, everything, or passing in just the trainer in this case here, and it will automatically figure out the hyperparameters and log them for you. So yeah.
Yeah, this is super, super awesome. I am excited to try it out and see possibly if we can start integrating it into VS or our own tooling. I really love it. So Alexander, you are obviously a super passionate community member. You've been with ML.NET almost since day one. How have you seen the community grow in the past year?
That's a great question. Excuse me. That's the water. It's been a great growth, I think. When I started maybe 2 years ago, it was a pretty small community, and it still is some way small community. But it's grown so much the last just half a year, since we did the virtual ML.NET community conference, and just in general around these things as well. And I see more people just chiming in and more talks around it in general, which is awesome to see, I think. And a lot of people just want to help out as well, especially for these libraries here. Just people from everywhere around the world, New Zealand, UK, Holland, and the US that just want to contribute as well to the community and come from a software engineering angle, which I think is great.
Yeah, and I don't know if everyone can see your shirt, but custom made. I love ML.NET shirts. John Wood actually designed these. We've had quite a few people order. I have one as well. And he has a onesie for his baby as well. It says, I love ML.NET, John does.
Yeah. We need more of these shirts. So, I mean, I think John needs a big order. So anyone watching this community stand-up today, I mean, reach out to John, put some pressure on him. We want a lot of these orders.
Yeah, exactly. I had another question and I totally forgot it. Well, that's okay. So do you want to tell them a little bit about what's coming up with the second ML.NET conference?
Yes, absolutely. So we had a great reception of the first conference, which is just awesome. We had, I think, 700 sign up across the world. And, when we started doing this, it was John Wood put on Twitter one day, before I even talked to him, that wouldn't it be fun with a conference on ML.NET? Sorry. And I was like, sure, let's do it. And he was not really prepared, I think, to jump into that deep as we all were. But we quickly formed a good team around it with Bree and Lise as well. And it was just great seeing like 700 people signed up so quickly, and we had so many people joining. So we want to make this a recurring thing, and we thought that, hey, in the fall, let's make it more of a hackathon, because like we have Hacktoberfest and so forth. So the November edition is going to be a hackathon version, and we're going to try to figure out a good format for that, and we're working on the planning right now. Probably we'll have a little short workshop beforehand to get anyone who's not familiar with ML.net started, and then kind of support anyone who wants support with solving a specific machine learning problem with ML.net of their choosing, I think. And then we'll kind of score the creativity and the accuracy of those models. And I think we'll have different kind of scoring cards, I believe, depending on how creative you are. Because in many cases you may have an awesome idea, but to solve something in 3 days without proper data is going to be very difficult, right? But if you can, present that vision and idea and say that, hey, the data wasn't really there, but with some work you can get it there, that can also be a winning contribution for sure.
So look out for more information about this hackathon. It's going to be in November when we're currently planning it. So look out for more information on that. And I actually remember my question from before.
Good.
I'm trying to stump you here. So if you could add just one thing or one feature, one thing to ML.net, what would it be?
Oh, I have so many things, and I speak a lot about this and meet a lot of people from the community, and I hear a lot what they want as well. There's a couple of things that I think are cool factors, which I don't necessarily always think they will add much like firm value for, and there are things that will add some actual value. So some of the cool factors, right, would be a Keras-like API for deep learning, that you can kind of create your own neural network. You can decide how many layers you should have, your optimization functions and dimensions, so forth. So you can do that yourself a bit. So we have full Keras-like API for .NET. And I think that would be really cool. And definitely will be use cases for that as well. Things that would be useful, I think, in general, is tighter MLOps integration in general. Because ML.net is an awesome tool to showcase what you can do with .NET, but we need to take it all the way so you can actually implement it at customer and clients and organizations in a way that is respecting the client needs and also making sure that it's auditable and trackable and so forth. And that, of course, depends on which organization you are. If you're a startup, it may just be sufficient to use AutoML and always deploy models from that and not track things too much because it just works. It's usually awesome. But if you're a government agency of some sort, you need to be able to provide explainability and an audit trail of which data is used and so forth. So I think just that would be a good thing to add as well.
Awesome. Good thing MLOps is on the roadmap.
That's why we're building it. So
that's awesome. Thanks, Alexander. I'll actually keep you on. We're going to move to Q&A. And Alexander, feel free to answer any questions as well. So I think I will go ahead and if anyone has questions, feel free to post them in the comments. I'll try and go back. Louise, if you see any that you haven't been able to answer in the chat, feel free to read it out and answer.
So I saw one question on there that was about a code first approach and having a little bit more control. I have a recommendation, which might not be exactly what you were thinking. Whoever it was that asked, I think I lost it in the chat here. But I would actually still recommend you kind of start with Model Builder, the CLI inside. So I'll share my screen again. One second.
Is it this question?
Good.
Oh, nice. Pops up.
That's it.
Maybe. I can't see it. 1 second. Yeah, totally. So Bree, I am sharing my screen. If you can show.
Because the text is
okay, cool.
smaller.
So you guys can. Oh, what? Okay. Well,
Control zoom in.
I'm trying.
There you go.
Why is it working? Here we go. So when you run Model Builder, before I kind of went over a little bit of the consume model where here you can pass in values and get outputs, like kind of that simple prediction thing. But we also give you the code that we basically use to train that model. So it gives you a good place to start off if you want to, kind of customize it yourself. So if you come in here, this is kind of a bad example because it's image classification. That just happens to be the one that I trained before. But if you came in here, you would see how we're taking all of your different columns from your CSV or TSV, combining them into features, passing it into the trainer, and then actually doing the training. So this would give you a good point to start from if you wanted to go and like try different algorithms or other things, and start customizing it more for your code first approach. So it's kind of like a code 1.5 approach where you use this to get you started. So you have a working pipeline that you can start manipulating and kind of making your customized adjustment.
Yeah, I'll also add in our samples repo, there's a ton of different examples that if you clone that project, you can also modify it based on your own data or your own scenario or swapping out algorithms. So that's another good way to start. Our docs has a ton of tutorials starting from scratch as well. But if you all want, next week or in 2 weeks when we have our next stand-up, we can totally do a deep dive into the code if you want to explain the different parts of the code. Just let us know if that's what you want to see.
I think just to add as well, I think the model builder is a fantastic start in many cases, like especially for new ML tasks. Like I'm not so experienced with ranking, so if I looked at that model builder or something, would be great just to get familiar with what's expected. But then when you want to take it to production, you definitely want to fine tune the code for your business needs because you will know more about the data than model builder will ever know because that's just the nature of things, and you can add more context to that. But it's a great start, I think, and also gives you a good structure of the code.
Yeah. I see another great question here. So what's a good approach for having a model continuously learn, like a text prediction engine that are trying to predict the next word? You just call fit over and over. Anyone want to take that one?
Continuously learn.
I can kind of touch on it, and then maybe people can add stuff to it. I don't think we really have support for that at the moment. Like nothing native. We haven't really thought about it specifically. But what you described would work. So like as you start getting more data, you can go back, iterate on the models, and perform fit. I think I read another question by the same person who asked like if you were while you were typing what you could do. So like if you would just wanted to like predict the next word or something like that, that wouldn't actually require retraining. There might be something you can do. It would be a pretty big model. I don't know if we have something great for that right now, but
have a sample of that. If our Blazor sentiment analysis sample, as you start typing, it will show, and maybe I can pull it up as we're answering more questions, but as you start typing, it'll go left or right if it's positive or negative. So I'll see if I can pull it up real quick.
So for that, you don't have to necessarily retrain. You can just recall into the model to do a prediction. But as far as like if you were trying to do like an autocomplete thing, similar to like Google's every search engine now I guess has the autocomplete. That would be, I don't know if we have a way to do that. I think that was one of the examples, but it's definitely something for us to think about. Definitely, if you have more use cases, toss them out, and we can try and figure out some way to use our tools to get there.
And just I think from the community here, I would encourage everyone to speak up as well on those things. Like this is a great question, I think, and I think the Stack Overflow forums has really started to expand as well on MLFet questions. So if you have these questions, you should ask them there, or you should open an issue in the GitHub repo, because the chances are that a lot of people have already thought of this and have either suggestions or they don't, and that's a great way to add a feature to the library as well, I think.
Yeah, definitely tell us your feedback. Feel free to contribute on GitHub. Go ahead, Luis.
So there's actually been a few questions around neural networks and being able to build neural networks with ML.NET.
Yes.
Go ahead.
No, exactly right. That's kind of one of my wish lists as well. It's the Keras-like API, and I can definitely feel that maybe it's not always much of a business value, but it's there's definitely a possibility for it, and it definitely brings the cool factor to the library as well. Especially considering that the net bindings on top of something like TensorFlow is going to be a lot faster than those on top of Python. So that's really exciting, I think.
And we also have, sorry, go ahead, Jake.
I was just going to say, I mean, it's on our wish list as well internally. I think that you guys can all help us kind of push it to the top of our priorities. If you come to our GitHub, perhaps we can create some sort of survey that we can add to the community links to this to let us know how you want to use it. Like, especially if you can give us like a business use case and a story, like, or just, if everyone's saying they really want it, then we'll really try to prioritize it. But yeah, it's super cool. We'd love to have it in .NET, and I think it's inevitable sometime. We're just trying to figure out when and how.
In the meantime, though, if that is an urgent need, you are more than welcome to use one of the community libraries out there that are created, such as Tensorflow.net, right, which actually ML.NET leverages for image classification training scenarios and for scoring of TensorFlow models. And there's also TorchChart, right, if you prefer to build models with PyTorch. So there's definitely options for .NET out there, but in terms of being able to do that currently with ML.NET, we, of course, if that's something that you'd like to see, please raise issues and vote that all the way to the top of the priority list.
So also, I'm not sure what I can share and can't share, but there's lots of projects going on within Microsoft around neural networks and such that we're hoping to leverage and build on top of. So some of this is like, how much do we do now in a world and a technology that's like changing rapidly, versus waiting for some of the other cool projects that are happening to stabilize a little bit, and then we jump on those. But yes, it's definitely not a problem we're like avoiding. We're investing in it. It's just, how do we bubble it up to .NET and stuff like that we're still trying to figure out.
Let's see. So this was I think this was a very similar question. So
yeah, and with this one, what you could do is for feature extractions, you can use, and I added it to the chat as well, but it's the DNN featureized image transform, right? And that's going to do kind of what I believe that you're alluding to here, Dean, which is you want to extract features from your images. And there's you can use the image analytics package, NuGet package, to perform a lot of transformations and any operations that you may need to perform on images.
Yep, and I think we have an example for like taking the features from an image and then tossing it into a classification model, and that actually performs fairly well to like do image classification. But you can imagine that you could take that data as one set of features, but then bring in other features as well. So the only example I can come up with in my brain right now is like, if you were going back to that like housing example, you could imagine you could take like a picture of it and pass that into like classification or something, and then take the output of that and pass it into a regression model to kind of help try to incorporate the quality of appearance of a home into the price or something like that. But that sort of model composition you could do.
This is the example I was talking about before. Let's see. My computer's running very slow though, so. Oh no. Come on, you could do it. So normally, this little ticker would go left and right, depending as you're typing in real time. This is actually in our samples repo, so you can try it out. I think just with, oh, there we go. With trying to share my screen and everything. This is,
as usual, Bree is doing 10 jobs and keep up.
There's a running joke, well, kind of a joke, that I've never had a demo that's failed live before. Which I'm pretty sure I just jinxed it by saying that. So we'll see. But John asked, when's the next stand-up? We're going to go every other week to start off with. So in 2 Wednesdays. Oh gosh, I think this
it was once a month. Well, that's exciting.
That means that you folks have 2 weeks to create awesome ML.NET projects and submit them so that we can talk about them.
Exactly, right? And join into all the fun. I mean, if you see, I also encourage the community here. If you see something that is not built by the ML.NET team, there's no reason not to build yourself. There's tons of things we need to build in the ecosystem, and not everything going to be built on ML.NET, I think. So just create your repos and create your NuGet packages and let people know. And I'm sure there's tons of people that wants to help out and work with you on that. I'm one of them, so.
And this question, presenter's intro, we did, but just really quickly, I'm Bree. I'm a PM on the .NET team working on ML.NET. We've got Jake.
Yep, I'm the dev manager. I lead a small team for all the tooling for ML.NET.
Yeah, I'm Alex. I'm a Microsoft MVP. I work for a company called Excella, and I just love being part of the community.
And I'm Luis, and I'm part of the Microsoft Docs teams working on ML.NET.
And this is Malibu. She's the unofficial.
She writes the checks.
So I wish. And it looks like maybe we can answer one more. Is it running on Blazor WASM? Louise, I know you're passionate about it.
I don't think that this particular demo is, and I was actually typing out the answer in the chat. But so Blazor WASM scenario is somewhat limited right now with .NET Core 3.1. But with .NET 5, you should see pretty much being able to use the full ML.NET inside of Blazor WASM. So stay tuned for .NET 5.
Yeah.
There was one more question I saw. I don't know if it got answered on data processing before tossing into the model. I think it's kind of outside of the scope of our tooling as far as like what Model Builder does. But yes, generally it does. Like you need to, at the very least, get it into like a CSV, TSV format, and it generally you will improve your model performance with some manipulation of the data to try and make it easier to train on. I think that we could probably dedicate some time to it in a future stand-up. But if you can come, I touched on this a little bit earlier. If you can like present us with how is your data now, like we can try to help get it to a state. We're not experts necessarily, but we kind of understand the tools. But we can kind of try to help make it so that your data is compatible with our tooling and gets a somewhat reliable model.
Yeah. Awesome. Well, thank you all for tuning in. Obviously, the recording will be on YouTube, and we will in the caption? Is that what it's called? in the info.
Yeah.
Comment down below. Subscribe.
And we will see you all in 2 weeks.
Awesome.
Bye.
Bye, guys.
Thanks. Bye.